Let us see one more problem on Norton's theorem. What is the question given? So he asked to find current through 2 ohms resistor which is connected between A and B using Norton's theorem. So we should find current through 2 ohms resistor which is connected between A and B. We should find this one. If you not watch the first video of Norton's theorem, I will place in the iCards and I will provide the link in description also. First you go and watch that video and come to this video. So from steps of Norton's theorem, the first step is we should identify the load. Here load is 2 ohms resistor between A and B. And from step 2 of Norton's theorem, we should remove load and short circuit this load between the terminals, and current flow in this terminal is IN. IN is nothing but Norton's current. So from step 2, if we draw the circuit look as follows. So this is how the circuit look like from step 2 of Norton's theorem. And from step 3, we should calculate the current flowing through this short circuit. Here current flow in this short circuit is IN. So from step 3 of Norton's theorem, we should calculate Norton's current. Calculate IN. For calculating IN, you may use of any technique. Here I am using mesh analysis. For mesh analysis, I am considering loop currents as this is as loop I1, I2 and I3. I am using mesh analysis, writing loop equations in loop 1. Here 2 plus 12 which is 14 I1 minus this I2 affecting on I1 through 12 ohms resistor. So minus 12 I2. Here I1 touching first negative terminal of these 2 volts. So minus 2 equals to 0. 14 I1 minus 2 I2 which is equals to 2. If we rewrite this, consider this as equation 1. And from loop 2, here 1 plus 12 which is 13 I2 was to 13 I2. Here I1 affecting on I2 through 12 ohms resistor. So minus 12 I1 which is equals to 0. Consider this as equation 2. And from loop 3, here this 3I3 and I3 touching first positive terminal of 4 volts. So plus 4 which is equals to 0. I3 is equals to, take and go this 4 to other side which is minus 4. Here this take and go I3 to other side which is minus 4 by 3. Here solving 1 and 2, we get I1 equal to, and I2 we got as 12 by 19. Here the aim is to find IN. So from branch current of between A and B, the IN is flowing like this, and I2 flowing along the direction of IN, and I3 flowing opposite the direction of IN. Now if we write equation, then I2 minus I3 which is equals to IN. Now what is I2? I2 we got as 12 by 19 and I3 we got as minus 4 by 3 which is equals to IN. If we solve this, N as 112 by 57. So therefore we get Norton's current as. From next step of Norton's theorem, we should find Rn. To find Rn, We should remove the load and replacing the sources with their internal resistance. Here we have 2 volt source and 4 volt source. We are replacing with this as short circuit. If we draw the circuit for to calculate Rn, the circuit look like this. If we draw the circuit for Rn, then the circuit like this. We should find the Rn in this direction. So here this 2 and 12 are in parallel, and these two are parallel to this 1 ohm. So if we calculate to here, we get equivalent resistance for this as 19/7. If we redraw this circuit with this resistance, then the redrawn circuit is look like this. Again we should calculate in this direction. If we rearrange this resistance with this A and B points, then the circuit look like this. Between A and B 19/7, and between A and B 3 ohms. Now these two are in parallel to each other. If we simplify this, we get Rn. Therefore the equivalent resistance between A and B we get as 57/40, which is equals to Rn. Therefore Rn is equals to 57/40. From last step of Norton's theorem, we should draw Norton's equivalent circuit. So draw the Norton's equivalent circuit. How Norton's equivalent circuit look like? Norton's equivalent circuit look like this. Here this is IN, this is Rn, and this is RL. RL is between A and B points, and RL is given as 2 ohms. Now from calculation, IN is obtained as 112/57 amps, and Rn is calculated as 57/40. From question he asked to find current through this 2 ohms resistor between A and B. Here current flowing in this loop is this IN current. The current flow in this loop as let I. If we write loop equation in this loop 2 or I loop, here we are going to get equation as this Rn plus RL of I current, and this IN current affecting on this I current through Rn. So minus Rn of IN, which is equals to 0. If we substitute the values, we are going to get Rn as 57/40 and IN as 112/57 plus Rn as 57/40 plus RL as 2 ohms, and we should find current through this, which is equals to 0. If we solve this equation using calci, we are going to get I equals to 0.175 amps, which is approximation of 0.82 amps. Therefore we are going to get current through 2 ohms is 0.82 amps. If you like this video, subscribe my channel.